All right, well, I guess we can get started. This is a good amount of people. Welcome to the app work group, app runtime platform working group. I think I got that right. I'll share my screen with the agenda. Okay. Cool. So I guess we'll start with Joshua and Joshua.
Yes, that's perfect. Can you hear me? Can you hear us? Okay, so a little disclaimer. This is, let's say, our first time that we show up in this meeting. So if we, I don't know, miss anything or I don't know, don't stick to conventions, how it's usually done here, yeah, please be with us. Yeah, today's topic from Joshua and me is about a metric that we introduced as a feature, which is about getting insights into the traffic of a container, of an application. In particular, what I mean by that is, yeah, getting insights into the bytes received and the bytes transmitted, so to say, which is helpful for various reasons. And so the plan today is that I will give a little intro, do a little live demo, and then Joshua will walk you through the code changes, the most important ones that we have done and where we submitted pull requests. So the goal of our appearance here is to raise a little bit awareness about that feature and maybe get some feedback or get some people wanting to view our pull request. Yep, so I'm going to share my screen. I can't. You are still sharing?
Go for it.
Can I? Okay, perfect. Thank you. So can you see it?
Mm-hmm.
Okay, perfect. So as I said already, it's all about container metrics. And let me start with the documentation about the Logregator container metrics. Here you see that we have various metrics for CPU, memory, etc. But yeah, as you can see, obviously, there is nothing regarding networking. And basically, we didn't start a journey ourselves. Someone else started it. At least this is one of the very first issues that we found related to exactly that topic, where someone asked, "Hey, yeah, man, CPU, memory, disk, etc. Everything is cool, but why don't we have something for network?" And we thought so too. So we took the time to come up with something. And yeah, let me just jump right into the demo. So on the left side, you can see that I'm querying constantly the metrics for CPU of a particular app. And here shows me the metrics for container 1 and container 1 and 2. And on the right side, you can basically see that I SSH into a container. And what I will do now is I will just abort that and show you the very first metric that we introduced. It's called RX bytes, means for receiving bytes. And on the right side, just to let me fire it up. So you see here, you see you see already that the metric is being submitted and it's being visible here. And what I'm going to do is I'm going to cause some network traffic by downloading a random 10 megabyte file. And what you will see after the download has happened, that from container 1, the 4 here, from container 0, sorry, the 4 here will jump to a 5, which is basically the proof that something has happened end to end. So let me fire up the download, and yeah, It will take some seconds. Yeah, give it a little more. And what you will see is, as I said already, from these 4 here will turn into a 5 very soon. So the download has happened, and from container 0, see it's still 4, and very soon, yes, there you go. It jumped to 5, means like the receiving bytes was around 40 megabytes so far, and after the download, it's around 50 megabytes. And we have the same for the transmitted byte, means like whenever we uploaded stuff or something. So let me query that, and you will see a very similar behavior when the metric from container 0 here will jump from 2 to 3. That's the wrong one. Yes. Yeah, just uploading that file now, and what you can see is that very soon it will jump. Yeah, you see here it went from 24 to 34, means like again we uploaded 10 megabyte. And yeah, this is basically already all the stuff that I wanted to show you, give you the intro and show you what we achieve, what kind of feature, how it looks like in real world. And I will hand over now to Joshua who will walk you through the most important changes that we have done in order to achieve that. And I will stop very soon to share. Yep, I stopped sharing, Joshua.
Okay. All right, let me know when you can see something.
Yep.
Yes, can see.
All right. Yeah. As Josh stated, we also quickly wanted to go over the code changes we did to implement the network metrics. We created 5 PRs in total. Today we want to go quickly over 3 of them, where we actually had to implement some logic and add something new. In the other PRs, it's mostly just forwarding information that we're reading here, so they're less exciting to look at. And the first one, or the first PR we created, is in the CF networking release. And the first change we did here was that we wanted to forward the interface name of the container, so the networking interface name of the container, together with the other information that is forwarded, like the container IP. And the reason to do that was that we want to read the network metrics in the guarding component together with the other metrics that are already there. And for that, we needed the interface name, which was not there yet. So that's why we added it here. And to expose this information, we adjusted the up method, which is called when the container is started. And there are not many changes in here, but the first change we did, or the first important change we did, was that we had to bump the expected CNI result version to 0.4.0. Reason for that one is that the previous versions did not expose the network interfaces, and this one does. This one works fine with the current Silk release, as we just saw in the demo. And after doing that, we get the first IPv4 IP address. This logic was previously hidden in this method. So it's nothing new. It's basically just moved from there to here. So we have the same external behavior as before. And the important part, what this allows us now to do, is that we can get the interface name that matches this container IP, and just attach it to the up outputs, which is then forwarded to the guarding component, which can then read the network metrics. So this is the first, I would say, important change. And this information is then used in the guarding component. So here we checked where the other network or where the other container metrics are read. And we just appended our code here to get the network stats. Here we were able to reuse the network stack property, which was already there from a previous implementation. So it seems that this was a leftover. And we were also able to reuse the container network stat struct, which was already there, and just attach our information that we're reading here. So what we do here is we get the interface name from the previously exposed information and use this one right here. So what we do here is that we call the run method, which was already there, which allows us to run a process and run a container. And this allows us to get the received and transmitted bytes for that specific container network interface. And we simply do this by using the sysfs file system. So this allows us now to read the outgoing and incoming bytes for that specific container. After that, nothing exciting is happening. So it's just some parsing, some validation of the values we're getting. And in the end, we're just returning the container network stats, which are then appended to the already existing garden metric struct. And the last step of this journey is then the Diego login client. So in the end, the executor will fetch the metrics and use the send app metrics method to send all the other metrics, which you already see here. And we just appended our RX bytes and TX bytes metrics, which we also just saw in the demo. And yeah, and this basically sends the new metric data to the log aggregator, and that's it. Yeah, that's pretty much it from our side. So yeah, as Josh already said, it would be great to get some feedback on these PRs. And yeah, thanks for listening.
Awesome, thank you. That looks really cool. I'll make sure someone takes a look at it in the near future. Hopefully this week or next week.
Right.
That would
Thank
be
you.
perfect. Thank you.
Yeah, that's really cool to see. Next up, it looks like, where is today? There we go. Patrick, you wanted to talk about load balancing algorithms.
Yeah, big footsteps to fill actually. So I'm way before such a state of the topic I want to discuss. So I'm more looking for feedback before we actually start any implementation or even an RFC for the topic I want to bring. So it's more like collecting feedback, what experiences you made in the past, or if you had similar discussions and decided against or for something by intent, and maybe can add or stop our ideas before we waste efforts. That's my motivation for bringing it. So as you I will not share a screen, so it will just be a verbal discussion. As probably most of you know, we support 2 load balancing algorithms in the routing stack or in GoRouter. This is least connection and round robin. You have to configure on platform level or on Cloud Foundry installation level which load balance algorithm you want to choose, and it is then applied to all applications. As you also know, we have a multi-tenant platform with tons of customers and very varying range of use cases. For us, there's every now and then someone asking for least connections. We are using round robin as a default setting for all our distributions, but every now and then someone asks for least connection, and of course then we can only say it will affect others. We won't change this global thing. Yeah, but it would be nice if a customer could choose their own load balancing algorithm on their own. So just one customer for their root or their org or space, whatever we can define, can select the load balance algorithm of their choice. So this is something we would propose as an RFC maybe to make the changes. I know it affects quite some areas. But yeah, I first wanted to see if you're open for it. The other motivation I want to give is that it also opens the door for more fine granular features. So like we could add new load balancing algorithms for some people to use. We have on mind to add more AZ aware metrics on the GoRouter, or like metadata on which AZ is this app instance living in. Is it the same like the Go router? Then we could build some like weighted round robin or weighted load balancing algorithm to choose or prioritize app instances in the same AZ. We know there is some discussion. We also have an issue. I linked it, I think. There is some pros and cons for this, but with this step one that I just like summarized, we could leave the choice to an app developer or have someone playing around with it even, and don't have to set a platform-wide setting. Also, we just received a request of another load balancing algorithm with some ring-based hashing, and it sounds very great, and we would like to support. But for us, we could not even support the stakeholder with this load balancing algorithm because we can't change it for all. So we are just blocked without making it configurable per app instance. So my question is, was this ever discussed, or were there some arguments against it, or is it just not implemented and everyone would say, yeah, it's nice to have, please contribute it if you're willing?
Yeah, it's definitely something that we've discussed in the past, and it just we just haven't had the resources to get it out the door, or dedicate time to it. But I think this is something that everyone would appreciate. Eric, did you have other thoughts? I saw you come off mute. Or maybe you
Yeah,
didn't.
I think, you know, I can see it being valuable to be able to experiment more with other routing algorithms at a granular level than just, you know, switching the entire environment over to something different. I think my main concern would be making sure that we're not making the developer experience too complicated or cluttered if people don't care about that and are happy with the default. And then maybe there's some edge cases around like what level of granularity would make sense for the configurability. You know, maybe the easiest thing to do would be per route, now that we can share routes across spaces and things like that, because that could potentially conflict with the space hierarchy that we generally assume is in effect. But yeah, I mean, otherwise, like, I think those all seem like things that could be resolved, and I agree with Jeff. You know, people have had ideas about this, but there hasn't been enough urgency or momentum to implement anything to date.
And there's nothing like that on any roadmap of anyone in this call, just to avoid duplication of work. But probably we should have an RC anyways if someone plans for it. So RC would be the next natural step, I guess.
Yeah.
Okay. Yeah, then I'm happy, unless there are other comments.
Cool. Thank you. Max, you wanted to talk about stale issues?
Yeah. I hope you can hear me.
Yep.
Yeah, perfect. It's more a question than really a talk. So from time to time, I've stumbled across issues that feel like they have some importance, or where we're waiting on feedback and they have been open and inactive for, say, 2 months or more. And it feels somewhat wrong to just keep them open for forever and just not take care of them. So the question is, if we are interested, I raised that previously on Slack, in something that could potentially close stale issues, or at least have a reminder for people where we wait on feedback to have like, hey, your issue is still open, please check if you can provide some further input, and then ultimately close them if there's no input and yeah, the reporter just disappears. Or if we have strong feelings why we wouldn't want to do that. It's basically a housekeeping topic.
Yeah. It's definitely a problem. I guess. Does anyone have strong opinions here.
I think
I had-
regarding
Go on. It's okay.
regarding automation, automated nudges, you sound like a good next step. I'm a little cautious of automating closing issues. I think the Bosch or Foundational Infrastructure Working Group has been thinking about that for a while, and there's maybe some concerns around being a little too rude to people in the community, especially if we chose aggressive timeframes for closing issues that aren't responsive. But maybe being a little more aggressive about manually closing issues that seem stale as another step towards reducing the volume of stale issues that we have across repositories.
I wonder if this is something that the TOC would be interested in, just for providing some mechanism, opt-in mechanism, like they did with branch protection, of adding some sort of automation that'll add GitHub Actions to do this for us and for other teams if they want.
Let me see if I can quickly find it, because there was some discussion around that. I'm not sure if I can find it. Ah. Oh. Right, here it is. Okay. Where's the chat? So it's the Ruben at some point opened an RFC for a common stalebot. And it wasn't really accepted, but the thing is that the end state is kind of weird, because a lot of people agreed that nudges or like reminders are a good thing, but then closing them is not. And instead of doing at least something, it was just discarded, I guess.
Yeah, I think this has been sitting in draft state for almost 2 years now.
Yeah, and that
talk about stale.
Yeah.
Kind of ironic now.
It kind of proves my point. Yeah. Yeah, I don't know.
Maybe just reactivate the RFC and like put it into non-draft state. See what comes out of it. I don't know.
But if nothing happened for the past 2 years, why would others do something now? So it's also a bit. Usually, every project on GitHub has some kind of automation about it. We can take a look what the others do, but I think, I don't know, 1 or 2 months would be enough time for doing something. In the past time, I was also working on some issues on the CF deployment, in the CF deployment repo. Someone opened something, then I will ask a question, they will wait, or some time would pass, or I don't know, for the some Slack threads where we had discussions, they will ask about some bug fixes, things to be fixed. We will suggest some things, how they can fix the things, and then you sit there and wait for a few weeks for an answer. But yeah, I don't know, maybe the people don't have the time, or they do it when they have to do things. So it's okay if we do some housekeeping and clean the things that we don't want to have them in our backyard. I don't know.
So
I think
we could also. Yeah,
go ahead.
Okay. So one thing we could also do is we could just say, I think most issues have at least someone assigned, that we just say, if you're assigned to an issue, make sure to close it if it's been inactive for 1 or 2 months. So we could make this a manual automation, basically. We could try that first. I don't know. But it feels like a lot of work, and I tend to lose sight of issues as well if they don't regularly bubble up in my notifications because someone wrote a comment, and having like a stale bot that just comments, hey, this issue's becoming stale, would make sure that it regularly comes up and I see it and get notified about it. That was kind of the whole idea.
Yeah, maybe rather than trying to solve this at a CF-wide level, if there's some experiments in the working group to do first, that could even inform what might be an effective community-wide policy. I think, I like the idea of, if we decided to have maybe a fairly consistent policy about issue responsiveness, that still seems reasonable enough, like a couple months or something like that. And then making that clear in any of those like stale nudges, then like that seems like a reasonable thing that we could try doing to start cleaning up all of these stale issues.
Yeah, and a stale issue notification won't hurt anyone, so you can always add an automation for it.
Yeah.
No one will be offended by it. I don't know. They've closed my issue. They don't want to discuss with me or things like that. That won't happen. But at least we'll know that something no action has been taken for a while.
Yeah, and the message clearly states something like, if you still have the need for this issue, feel free to reopen. I hope that everyone can do that. In that case, this will be an easy fix. So if you're interested, GitHub has a new search for issues, and I quickly built this query which searches all open issues on the Cloud Foundry org which haven't been updated in the past 2 months, and it's like 1.7K issues. Yeah.
That'll be fun. Would you want to volunteer for a proof of concept of the automation for this, Max?
Yeah, so the one thing that's pretty obvious is there is a stale action from GitHub directly, but I think that only works repository level. So I'll probably be looking into something that runs on an org on a limited set of repositories. Yeah, I can see what I find and probably share some details in Slack, and we can continue the discussion over there.
Perfect. Awesome. Does anyone have other things to bring up or talk about? All right. Well, I guess that's our meeting this month. Good to see new faces, and we'll see you next month.
All right.
Thanks for hosting, Geoff.
See you.
See ya.
Bye-bye.
Bye. Thanks.
Bye.